Hello everyone, this is Dr. Zach. So today we are going to learn about the product and quotient rules, as well as how to apply these rules to our 6 basic derivatives. While working on today's lesson preview, question A became a lot easier once you used monomial division to rewrite your problem. The monomial division allowed you to apply your derivative rule directly. Question B took a lot of algebra as well. Once you rewrote the problem, eventually after multiplying out your trinomial and dividing by your monomial x, you should have come up with an expression x to the third minus 2x squared plus 5x minus 4 plus 4x to the negative 1. After that, it should be smooth sailing, applying your power rule. Question C, average rate of change. I just wanted to remind you that the average rate of change is the slope of your secant line. And in this case, it would be f at pi over 3 minus f at 0 divided by your pi over 3 minus 0. Substitute and you're on your way. Question D. All right, so you're looking at it. Monomial division does not work. You don't know how to do this one unless you use the limit definition and take the limit as delta x goes to 0 for f of x plus delta x minus f of x divided by delta x. But if you tried that, you're a superstar, and this one was a bit of a challenge. Hopefully after today, it becomes a lot easier. Problems such as question D make our first rule essential. This is the product rule. It was created by Gottfried Leibniz in the 1700s, and the product rule is used whenever you have a complex function involving multiplication. So we're going to prove the product rule as best we can. So in order to find the derivative, h prime of x, remember what I said, we always go back to our limit definition. We're going to have the limit as your delta x goes to 0 for f of x plus delta x times g of x plus delta x, and then we're going to subtract f of x times g of x and divide by delta x. So that's the definition of the derivative using limits. So in math, we work very creatively and always keeping our limit notation. One of the cool tricks in math is you can multiply by 1. That's the idea of multiplying by the conjugate. Or you can add 0. So in order to prove the product rule, we're going to use the premise that adding 0 will make this easier for us. So the form of 0 that we're going to use is we will add in g of x times f of x plus delta x minus g of x times f of x plus delta x. And we continue to write minus f of x times g of x, all divided by delta x. Essentially, we have added nothing. And simplifying or rearranging the problem leaves us with a limit as delta x goes to 0. We're going to group this time the terms f of x plus delta x times g of x plus delta x with minus g of x f of x plus delta x. After that, we group our other two terms, which gives us with plus g of x times f of x plus delta x minus f of x times our g of x. Each one of these is divided by your delta x. Now look closely at what has happened here. As we go to 0, we can do a little bit more factoring. We're going to get the limit as your delta x goes to 0, and we're left with f of x plus delta x factored out, g of x plus delta x minus g of x divided by delta x. And the other expression is going to be g of x times f of x plus delta x minus f of x, all again divided by your delta x. Now, if you look closely, what I hope that you see is that this portion and this portion are the definition of the derivative. So if we take as delta x goes to 0, we're going to have delta x going to 0 for the first part, and we're left with f of x times the definition of the derivative for g prime of x plus g of x with the definition for the derivative for f of x. So our derivative of h of x is f of x, g prime of x plus g of x times f prime of x. Now, I'm going to often refer to this product rule as first times the derivative of the second plus the second times the derivative of the first. You might be wondering if it's necessary for you to know how to prove the product rule, and the answer is no. However, what I do want you to understand is that everything we use in calculus has been created by some mathematician, and we may not truly understand the proof, but we should admire and enjoy the fruits of their effort. Now it's time to take a look at our first example. As we look at each problem, you should recognize when you have a product. So in this particular example, we have 3e to the x as our first term multiplied by the expression 3x squared plus 5, and we're going to call that the second term. So the derivative, f prime of x, is equal to the first term times the derivative of the second term plus the second term times the derivative of the first term. And if we follow through, that's going to be 3e to the x for the first term. The derivative of the second term, following our power rule, is going to be 6x plus the second term, which is 3x squared plus 5, multiplied by the derivative of the first, is going to be 3e to the x. Now we're simplifying. That gives us an 18x e to the x plus, distribute your 3e to the x, that gives us 9x squared e to the x plus 15e to the x. And you can rearrange it if you'd like, but this is our derivative, the first product rule of the course. As we look at example 2, all right, I definitely see a product we're going to call the first binomial expression and the second binomial expression. But you know what? We should do some algebra to make our problem easier before we think about the product rule. So we'll rewrite our problem as x to the negative 1 plus x to the negative 3, and then we will get working on the product rule. So product rule, g prime of x equals the first term times the derivative of the second term. The derivative in this problem is going to be 9x squared plus 3. So that's the derivative of the second. Plus our second expression, 3x cubed plus 3x times the derivative of the first expression. And the first expression will be negative 1 x to the negative 2 minus 3x to the negative 4. Now, simplifying this expression does not seem to be a good use of our time, so we're going to go forward with example 3. Now let's see what we can do with our trig problem. As you can see, we have sine of x times cosine x. The negative 1/5, let's pull that out into the front and consider negative 1/5 sine of x as our first term. Then we can look at the cosine x as the second term. Following the product rule, t prime of x is equal to, now we have the first times the derivative of the second, which of course is your negative sine of x, plus the second, which is your cosine x, times the derivative of the first, which is negative 1/5 cosine of x. Clean it up just a little bit. Maybe you factor out your 1/5, and you're left with the sine squared x minus the cosine squared x. What about this problem? So we have f of x equals 2 times the quantity x squared plus 1. It kind of looks like 3 factors, but the constant 2 is not going to affect the problem. So we will consider 2x squared plus 1 as the first and the natural log of x as the second. So f prime of x equals first times the derivative of the second, well, there's your 1 over x, plus the second times the derivative of the first. The 2 stays in front, and into multiplying by the derivative of x squared is 2x. We do want to clean this one up. It doesn't look very kind, so we have 2 over x times x squared plus 1 plus, and we pull the 4x in front of the natural log so that the 4x doesn't seem to migrate into the argument. Let's go back to the lesson preview for just a minute. Do you recall that question D said f of x equals the sine of x divided by x squared plus 1? So f of x is obviously not a product. So we need a different rule, the quotient rule. So look at the quotient rule for just a minute. It's a bit complex. However, let's go over the proof because I love a good proof. Starting with your limit definition, we get the limit as your delta x goes to 0 for f of x plus delta x over g of x plus delta x minus the f of x over g of x, all divided by your delta x. Now, we should probably clean this up and make it so that we do not have a complex fraction. So we're going to multiply by g of x. We have f of x plus delta x minus your f of x times gx plus delta x divided by that common denominator, g x plus delta x times g of x times your delta x. Now, you must be thinking, what clever piece are we going to be adding and subtracting into this function so that we will have the derivative that we want? So let's give ourselves some space. And in this time, we're going to be subtracting g of x times f of x. But of course, we'll also add g of x times f of x. So with that small addition of nothing, we are going to be able to complete our proof. Now, should you be able to figure out on your own what to add? No. Once again, you must just learn to appreciate what other mathematicians have proven for us. All right, now we're ready to regroup our problem. As the limit delta x goes to 0, we're going to factor out a g of x and be left with fx plus delta x. So we have f of x plus delta x minus our f of x. Ooh, this is looking juicy. And then we will have plus, let's see what we can factor from here, f of x times g of x minus g of x plus delta x. Now think about your denominator. Each of these pieces needs to be divided by delta x. So I'm going to conveniently place them here. And all of this will be then divided by g of x plus delta x times g of x. All right, so I'm hoping that you see where we're going with this. F of x plus delta x minus f of x over g of x is dun, 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 a derivative. G of, it's backwards though, the second one. So what we now have after we apply the limit as delta x goes to 0 is g of x times f prime of x plus f of x times the negative g prime of x. You know what? We're going to actually not have a plus. Let's do a minus sign in here to accommodate the negative. All divided by your g of x squared. All right. Wow. That is the proof for your quotient rule. So there are three different ways for you to think about this one. My unscientific way of doing it is thinking bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. All right, another way to remember it would be low d high minus high d low over low squared, or of course, you could know the formula. And now let us apply the quotient rule. We're going to let 2x minus 1 be considered the top of the function, and x plus 3 is going to be considered the bottom of the function. So y prime equals the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom term squared. Now this one should be simplified. And when you simplify it, you have your 2x plus 6 minus 2x plus 1 over your x plus 3 squared. And we end up with a nice little 7 over the quantity x plus 3 squared. Now remember, this is a derivative. Second quotient, oh no, oh my goodness. This isn't the first derivative, this is the second derivative. All right, let's see here. We are going to have to once again rewrite the problem using the derivative. We're going to have the bottom expression times the derivative of the top minus the top, notice those parentheses, times the derivative of the bottom over the bottom term squared. There we go. Whew. Oh man, we should clean this up so that when we find our next derivative, it'll be a little easier. So we will have 2x plus 3 minus 2x minus 2 over our 2x plus 3 squared. All right, that looks much better when we simplify and get d dx of 1 over 2x plus 3 quantity squared. Oh no, but it's got the quantity squared. So we better rewrite it one more time. This is d dx 1 over, because remember, the rule cannot have that extra squared in there. So this will give us a 12x in the middle plus 9. All right, now I'm ready for the quotient rule again. So d dx of 1 over this function, find the derivative. That's going to be equal to your bottom expression, 4x squared plus 12x plus 9 times the derivative of the top. Oh, that's 0. Minus the top times the derivative of the bottom, which is going to be 8x plus 12 over that bottom expression squared. I'm going back to 2x plus 3 quantity squared, which makes it 4. Clean it up, and I will have a negative 4 times 2x plus 3 over the quantity 2x plus 3 to the 4th power. One last simplification, and we are done with the problem. So, as you've probably figured out, these are going to take some effort to practice. It is important to do the practice, all of it. Let's look at the next page. So it's time to try a little bit of practice with this quotient rule. 3 through 12 take about 10 minutes. Turn the video off and then check your answers over. So check over these two answers. You did come up with a rule. Question 4 is one of those rules that you need to have in your list of things you know. The derivative of the tangent is equal to the secant squared. I have a couple of reminders for you as you do questions numbers 5 through 8. The natural log of 1 goes to 0. For number 6, you came up with a rule, a new rule. The derivative of the secant is equal to the secant times the tangent. For number 7, you came up with another new rule. The derivative of the cotangent is the negative cosecant squared of x. And a reminder for number 8, algebra first. Do your algebra, then find your derivative. So our last 4 questions are pretty straightforward. Just a reminder, you should know your unit circle trig, be very, very proficient and fluent in unit circle trig. And a reminder again, number 12, algebra first. Always try some algebra before calculus. So from our work today, you found some new rules. You have 4 new ones that you are to have in mind at all times. The secant, tangent, cosecant, and the cotangent. You know the derivatives of all 6 trig functions. All right, so if you have a little bit of time, you can practice on questions numbers 13 through 18, and then check your answers. Once again, did you notice we're writing the equation of the tangent line? Very important concepts here. So as you complete your lesson follow-up, make certain that you are checking your answers that are provided with the book. If you'd like to only do the odds, that's fine. Just get some practice. Make certain you are excellent at recognizing a product rule versus a quotient rule. So a little bit more practice and you will be an expert. You have a great day.